Hey there, everyone. Daniel Lowrie with Anti-Siphon Training, and welcome to the first, well, at least that I've been a part of, live MetaCTF walkthrough pre-show banter. We are not starting the show quite yet. We like to get warmed up. We like to have a little fun, a little get-to-know-you session with everybody that's joining us today, including myself, because that's more fun, right? So that we don't waste time doing all that stuff. We have plenty of time to get through all the cool challenges that were in this month's MetaCTF. So, that said, let's introduce the panel of experts that I have brought in for you good folks today. Let's start off with none other than one Mr. Roman. Roman, welcome, sir. How are you today? Tell us a little bit about yourself.
Hey everyone, my name is Roman. I'm the co-founder and CEO of MetaCTF. I've been running CTFs for over 10 years at this point. Love doing it. My team and I recently, for the past year or so, have been running these monthly flash CTFs, and I've been working with Anti-Siphon on this, and so we're excited to walk through some of the solutions here today.
Awesome. It's going to be a good time had by all. Also joining us is none other than one Mr. Nikola. Nikola, I'm saying, is it Nikola, not Nikola,
No,
not
you're.
Nikola? I'm sure you've heard many variations thereof
I've
of your
had I've
name.
had like 6 different names, but no, you're saying it perfectly. I
Excellent.
apologize for
Tell
my
us a little
bad
bit about
audio.
yourself, Nikola.
Hey, it's good to meet everyone. I guess I'm the sysadmin for MetaCTF. I've been here for about 3 years now, give or take. And yeah, excited to go through a few of the challenges with you guys.
Oh man, I feel like I'm one of the Bobs in Office Space right now. Nicola, what would you say it is you do here at MetaCTF? Go into a
Um,
little bit of detail. I want
mhm,
to tease some of this stuff out of you guys because I mean you
Mhm.
built this product, right? You got this MetaCTF product. Everybody that's coming today obviously is a huge fan because they want to know like how you solve these things, how what goes into creating them. People are really interested in this kind of stuff, and it's a lot of fun. It's really great for us out there that need to, you know, challenge ourselves or learn a new skill or find out a new tool. So it can be really cool for that. But your job, or like, what part of that do you play, Nicola? How do you help build and maintain MetaCTF for us to enjoy?
yeah, so as the sysadmin, I do a lot of like the challenge hosting. So you might have noticed we've got a lot of interesting setups for hosting some of the challenges. I don't think we have any this month, but often we'll have like Kubernetes containers that, to make sure people don't interfere with each other as they're solving the same challenge. We have a system that you can click, it'll spin up a container for you. That's only you have access to it, and when you're done, you can click delete and it gets rid of it. So we have a lot of systems like that for hosting all the intentionally vulnerable challenges for people to exploit them. Um, and yeah, there's just a lot that goes on behind the scenes of setting all that stuff up. We've got a really talented team of challenge authors that will send me a bunch of zip files or GitLab links of the amazing challenges they've created, and I've got to get them hosted somewhere and set up in such a way that they're vulnerable enough that you can web exploit them or binary exploit them, but you can't you know break the system that they're running on, which
Because
mostly
that would
just
be
comes down
bad,
to
right?
it would be pretty
Yeah.
bad. We consider
Gotcha.
Well,
that a negative.
Important
I'll
safety
jump in.
tip, kids.
I'll jump in and say that Nicola's actual title is Director of IT. I think he started out as a sysadmin, and so I mean I think in some ways it still feels like
Yeah.
Nicola also makes some of the challenges. I think his favorite category is miscellaneous, so anything to do with anything that doesn't fit into any other categories. He's usually the main challenge author there.
Gotcha. What about you, Roman? You're the puppet master behind all this, right? You're the guy pulling all the strings. You're smoking big cigars. You got a big shot of whiskey on your desk. You're like, I'm making deals, right? But no, you're fairly involved with this as well, right?
Mhm. Yeah, I
Tell
mean,
us a little
so
bit about that.
I started out so the platform, a lot of the content that we wrote in the beginning, I did most of that. Now we do have a larger team of content creators, of software devs, um, but I still create some challenges. I still work on the platform. A lot of times I'm just sitting on calls and doing things, writing emails, but I still try to be technical.
Heavy is the head that wears the headset. It
Hmm.
is true. Now, what's your favorite kind of challenge that you guys do?
I think for me personally, web exploitation is my favorite one because usually they have a relatively straightforward path once you kind of look into it, once you try and figure out what, how the application works, and it's always kind of a puzzle. where you're usually given enough information to solve it. I think people in generally prefer OSINT and reconnaissance because that's where you get to find information about random targets, about random individuals, random companies, domains, hosts, using publicly available information. And usually those puzzles, scavenger hunt type challenges are really fun.
Nice. I'm with you. I really enjoy a web exploit. They're just good fun for the kids, right? Like it's like, and you get with your every Happy Meal, you get a web exploitation challenge. That would be a lot of fun if
Yep.
that were the way McDonald's rolled. I mean, it changed their business model completely, but be a really interesting take on the Happy Meal prize for sure. Well, I'm really looking forward to today. And with that said, this is pre-show banter. If everybody's just kind of joining in, if you're a little late to the party from when we started 6 minutes ago or so, we're just kind of bantering, getting warmed up, getting ready for the actual party where we're gonna walk through each one of these things for that MetaCTF has for us, these challenges, and they're going to vary and in their both their scope and their uh, category, as well as their what's the word I'm looking for? Whether or not it's beginner friendly, intermediate, we have something for just about everyone. So that's really kind of cool. I like that. That it doesn't matter where you're coming from. You could be straight noob, or I've been I've been coding in C for the last 30 years, and I love a good challenge. If you're that kind of surly old crotchety person, which I kind of enjoy, I like playing that character anyway. It's a lot of fun. If you have that experience underneath your belt, then you probably find something here that you're going to enjoy. But that said, we've kind of got this whole get to know you thing going on, which is a lot of fun. But let's just get into some interesting things. Like, let's start with Nicola. Nicola, what is it that's like really interesting you right now in tech? What's the thing that's, and I get it if you say AI, so don't feel bad. We don't judge here if that's your thing right now. But if you are going to say AI, you have to go down the rabbit hole. You have to tell us exactly about about AI you like. But what is it that's kind of tickling your fancy right now? What are you interested in?
Um, does it have to be a wider topic, or can it just be me personally?
It can anything, yeah, whatever.
Cool.
There's
Yeah,
no wrong
I've
answers
been
here.
valid. Yeah, I gave a talk at a KakalakiCon actually a few weeks ago on this. It's a conference near Raleigh, North Carolina. A lot of fun. But for the past year or two, um, some friends and I have been working on reverse engineering some old digital telephones. There was this company called Roll in the 80s, the 70s and 80s. It's totally defunct now, but they made a bunch of these digital telephones pre-VoIP, but using a weird proprietary protocol that's not really documented anywhere. My old university used to use a bunch of them. So we basically found them, they're throwing them out, they're selling them to surplus. We found a bunch of them, and we're trying to revive them, build our own circuit to drive these phones and just use them as normal desktop telephones. It started off as it'd be funny to do this. It maybe take a week or something, and it's been 2 years. Obviously very on and off, but it's a lot of fun. We've gone into the depths of figuring out the actual electrical interface involved. It's not quite as simple as just sending bits down the wire. They use a bunch of analog processing so that two signals can go in the same way on one pair of phone cable. And we've been digging through old patents and basically fuzzing these phones with different techniques to try and figure out how this protocol works. I see someone mentioned it in the chat. Thank you. And yeah, sorry, it's too much to get into now, but protocol reversing and hardware stuff is what I've been trying to get into recently, and it's a ton of fun.
Actually, that sounds really cool. Like, it reminds me of the old school hackers from back in the day, right? Where they were just like, hey, technology, interesting. Let's read about everything we can. And you know what? I think we could do this. Oh, well, yeah, if I help and I do that. And then, you get some friends together and you start messing around with stuff. And the next thing you know, you've either built some new tech or you found some new exploitable research or whatever the case is. And then that gets published and you're doing talks. It's like that to me, it is cool. So I love things like MetaCTF, right? Where you can go in, they kind of give you, you point us into a direction of things that we can learn and build upon. And you guys actually do kind of take that approach of, hey, get out there and start doing some research. Don't just expect us
Mm-hmm.
to, because there's plenty of CTF platforms out there, and it ranges really. And I think they all have their place in the space of super, let me hold your hand and tell you this is what you need to learn. Here's the information you should learn. Now go ahead and try that information I just taught you and in the CTF and see if you're able to have success with that. If so, great. Green light, move on to the next thing. So we go from that end of the spectrum all the way to, hey, here's something. Enjoy. Tell me if you find something there. That'd be awesome, right? And then do a write up after we, retire it. Which makes sense, right? You don't want to just everybody going out there and reading the answers. But I really like that is still happening. There are still people that just look at technology and go, that's really cool. It's interesting. I want to learn more about this. And then look at it from a hacker's perspective of, okay, I
Yeah.
see what it does. How can we twist and bend this thing
Mm-hmm.
to our own ends? And twist your mustache. This will be fun. Take that, Superman. So kind of fun stuff there. What about you, Roman? What are you like? What are you really into right now? What's tickling your fancy?
Well, first, you're talking about kind of the hacker mindset, and I think before I answer your question, I think in a lot of ways, the CTFs that we run, their goal is to kind of help people get into that mindset instead of trying to look at a website and trying to look at an application, just using it as a user. CTFs are really good at encouraging people to kind of think about what happens when you click a button, when you do something like what's happening in the background. And as you're trying to answer these questions, you learn about different tools, different techniques, different technologies. CTFs are great at teaching specific skills, but I think one of the bigger benefits is that it just helps you think about technology differently. Let's see. I mean, so recently I've been back in high school. I was really into like Raspberry Pis and Arduinos and like hardware, and I haven't really had the time to touch it since like my first year of college. Um, we're gonna be we're gonna be at like 5 different conferences next week, so all of us are traveling. But at one of the conferences in Florida, I'm actually going to be bringing a dozen or so like physical boxes that have a like a mag lock inside, and people have to hack into them, and so they open them and they see the flag inside. So I've been kind of going back to what I used to like to do, and just doing some soldering, drilling, putting these boxes together. Yeah.
Well, make sure you have a well ventilated area because I know anytime I do some soldering, the whiff of that
Yeah.
flux and whatnot is just like, I've got a wicked headache now. This is probably not good for me.
I finally got one of those exhaust fans that it's not just like a box fan that like pulls air in. It has like an actual arm that sucks in the air, so you can
Oh,
position it right
nice.
where the soldering is happening. And if you put on the right filter, I think it should actually filter a lot of the smoke, because I think
That's great.
those usual fans, they don't really. I think they just kind of pull it away from you. They don't usually filter it out. But
Any recommendations on kit or gear for people that are interested in the same thing? Like, what if you were say a brand new person came over and said, I've really heard about this whole hardware
mhm,
thing, maybe Arduinos, maybe Raspberries, maybe whatever. I want to get a solder gun. I want to
mhm,
get a station ready. What would be, this is Roman's newbie kit
mhm.
for hardware stuff includes go.
Um, I don't think you need to go straight to soldering. You can just start with a breadboard. There are plenty like sub $50 Arduino kits on Amazon, and I think those are really useful. They have a bunch of LEDs, resistors, transistors, like different sensors and things that you can connect to an Arduino. Um, I think Arduino is great, but you have to. Um, I think you're somewhat most. If you go with the basic one, you're mostly limited to writing in C. Um, recently, Raspberry Pis are great too. They're more powerful. You can install like a full operating system on them. Um, Often those, if you're trying to learn specifically about the electronic side of things, then I think Arduinos are probably better in the beginning. But if you're trying to create more complex systems later on, like with IoT, Raspberry Pis are really good. I personally really like Raspberry Pi Picos. They're kind of like a mix of Arduino. Um, they don't have a full operating system on them, but you can write, you can write in Python and compile that. And so maybe eventually, if you start with an Arduino, go to Raspberry Pi, and then once you have a project that you're trying to develop, you can find a more proper microcontroller for that once you're ready.
Cool. Good to know. Good to know. Someone's recommending ESP32 stuff. I
Yeah.
actually have one of those. Like,
hmm
it was right here. I must have moved it off my desk. Those are also a lot of fun to play around with. You can get those to do all sorts of
Yep.
crazy little fun things, and great for a project, and super cheap. So
Yeah. And the really nice thing about them is that they're low power, so you can put a rechargeable battery on there, and they're going to stay on for a while. They also have Wi-Fi and Bluetooth, and so you don't need
yeah,
to. But Raspberry Pi Pico 2Ws, I think, are more power efficient than ESP32s, and I think they
really.
have the same functionality. And so um, I'm not 100% certain, but I think the Pico 2Ws might be a really good alternative to ESP32s.
I've played around a bit with the ESP32s of like because it has a built-in functionality for a web server. So just
Mhm.
doing some really rudimentary, fun kind of web server stuff. I'm like, how small, light, and fast can I make just a simple something, like a simple tool to do X, Y, or Z, and I just have to bring up my phone, get the
Mhm.
browser up, click the button, and something happens. So
Yep.
they are a lot of fun, but I'll have to start messing around with the Raspberry Pico stuff a little more and see if I can't port
Mhm.
everything that I've done
Mhm.
over to that platform. That sounds interesting. What about you, Nicola? What's some good gear, some good tech you would recommend somebody new to the field to get into, whether that be software, hardware, whatever?
I will second the Pi Picos are great. I think RP2040, you often hear them referred to by that name. They have a really nice feature called PIO, like programmable input output, that a lot of people keep talking about. If you're doing anything involving like, I guess the name says it, programmable input output, like a custom input output. Um, it's really nice. It's like a little, I don't want to say virtual machine, but like almost like a little separate CPU core that just handles input and output, and is very configurable. That's what we're using for this project. It's really nice. Um, One thing I've done recently is if you want to get an oscilloscope, which you might not need if you're doing something involving purely digital signals, a logic analyzer, which is way cheaper. You can get those for like what, $20. A logic analyzer can get you very far, but if you're doing something that touches on the analog domain, and you want like a full oscilloscope, I mean, there are like really cheap USB ones that probably work fine for a lot of purposes. But a really popular one is Rigol, Rigol. I don't remember the exact model name, but you can find it on Google pretty easily. There's a model of scope that basically they sell for like, I want to say 50 megahertz. I think it's megahertz, 50 megahertz bandwidth, but you can really easily hack it to upgrade it to 100 or maybe even more, and also add in a bunch of other features. Um, I don't remember the details off the top of my head, but it's findable on Google. And yeah, there's a bunch of these you can find used on eBay for relatively cheap, $200 or so. Um, yeah, that's my two
Awesome.
things, I guess.
Yeah, very cool. Someone in the it looks like Sophia Engval asks,
Mhm.
or says that they tried GPIO for a Raspberry Pi 4, but only with Python. Seemed very limited. What are you using?
So I think Python is probably theoretically is less limited. Well, I mean, it depends how you think about it. Um, on a Raspberry Pi, I think it's easier to multi-thread. It's easier to spin up multiple processes. They're running things at the same time. Um, one limitation of Raspberry Pis is that they don't do analog signals well, and so they're mostly dealing with digital signals. So you can only like turn things on and off. You can't actually measure the voltage or have a sensor that measure, for example, you have a photoresistor. Newer versions of Raspberry Pi might have an analog sensor, but like on an Arduino, you can see how much light is going into the photoresistor. On a Raspberry Pi, it's mostly just yes or no. Um, but um, if you're trying to work with analog signals in Raspberry Pi, I think they usually have like modules that you can plug in, SPI or I2C modules. Um, yeah, but I think that's probably a good one limitation of a Raspberry Pi. But in general, I mean, because Raspberry Pis have a full operating system, you can have a web server running. You can have, you know, connected to some kind of remote service and have like a message queue and all kinds of things going back and forth, connected to a lot of other devices. You can do a lot more things with the Raspberry Pi.
Yeah,
Um,
it just has a ton of versatility, it would seem, to go that route. So, maybe if you just had one specific thing that you wanted to use for like ESP32 or whatever, that would be the way to go. But if you want something that's kind of going to be a jack of all trades,
mhm,
Raspberry Pi might be what you're looking at. Of course, there's always trade-off, right? That's just the thing about it. Is you
Yep.
go, okay, well, I'm going to lose some of this, I'm going to lose some of that,
Mhm.
but I'm going to gain these things. And as long as that math makes sense, right? What do they say? As long as that maths, you're going to be good. So that's what you end up going with. But very, very cool. I love this conversation. I get to talk about hardware stuff too often. Most people aren't really into that. Usually it's all, web app security and AD, which is very, don't get me wrong, I get it. Lots of fun to be had there. But the fact that you can just, grab an old device and, you know,
Mhm.
get a connection with a UART and start looking at firmware and dumping firmware and looking for, like, that's so much fun to me. And you can do that. I don't need, for that kind of thing. But even though that would be kind of cool if you guys had a, have you done a firmware challenge before in MetaCTF? Kind of new to the MetaCTF game, so you'll forgive me.
Yeah. I think one of the issues we often run into is that we have to have challenges that are solvable by everybody. And so
Mm,
often if we're at a conference but just don't have enough hardware like to provide everybody with the same equipment. And so what we often do is we like give people dumps of the firm, like
right.
compile the firmware, we give it to them and have them reverse engineer it, but then actually have them pull it out. Often when we go to conferences, they might have these fun like digital badges. Maybe I should.
Cool.
I have like dozens of them. Maybe I should put them somewhere in the back wall. But often those conference badge developers will include a few challenges. They'll have you pull something off the badge, hack it in some way, and we'll love when we go to a conference. We'll love partnering with those folks and adding some challenges in the CTF that way.
That's cool. That'd be a lot of fun. And get some people a little more familiar, a little more
Hmm.
comfortable with messing around
Yeah.
with firmware and the tools that are for that, and then of course any of the hardware stuff. So
Hmm.
that would be awesome to see. I would look forward to that myself. I always enjoy
Well,
when there's a soldering
mhm.
station at a con. It's like, oh, I'll be right over here.
One of the
And even
challenges
before,
today might be a little hardware-esque, but I won't spoil it yet.
Okay, yeah, a
yeah,
little hint, but not a spoiler.
yeah, for the conference next week, we're gonna have a challenge where we're going to give you a circuit board, a bunch of logic gates, and you have to look at the circuit board, figure out what's happening, and then essentially jump a few wires um, to make sure that the logic computes to whatever the answer should be. Um, but if you're trying to get into electronics, I mean, even before you get an Arduino kit, I think a really nice to have tool um, that you'll probably really enjoy using is a multimeter. So if you've never used one, I think it's a very cheap, fun, and simple tool that will get you pretty far with doing just random things around your house. Fixing random things, like a wire broke somewhere, you can just quickly test it to see if that's the issue. That might be like a gateway tool to get you into electronics. And you can
Yeah,
get them for like $10, $15.
I got mine at like an auto parts store, and I did a video one time on just finding a UART, and somebody was like, "That looks like the cheapest multimeter I've ever seen in my life." I'm like, "Yep, that's exactly what it is." But it does what I needed to do, right? It's not,
Yep.
you do not need to spend a bunch of money, and that's kind of why I wanted to use that, because I could have a Fluke or something really nice on the desk, and those are great tools. And if you are really getting into things like that, that's definitely the way you should end up going eventually. But starting out, I don't want people to think that, oh, there's a big ticket price to entry on this. It's like, no, you can go to your local auto parts store or hardware store and grab literally the cheapest multimeter on their shelf. That's
Mhm.
probably $10, and that will suffice for a while. I mean, and you can do a lot with that, just being
Mhm.
able to take those readings, check for ground, looking at voltages and things. That's really most of the time all you need to do. So I was cool
Yeah,
with, like, yep, that's a cheapo and it does the job. So
and I think the most practical use case for it is just checking battery voltage. Like for example, you have a device and you have, 6 batteries, and you can actually go in and see that, all of them drop, start at 1.5 volts or 1.6 and then drop down to like 0.9 volts. And so, yeah, that probably means the battery's dead. But sometimes you might go in device and see that like all the batteries are still full. And then you might know that, something's wrong with the device. You can, if Ryan, you share my screen, I'll show you a photo from a conference that Nicola did. We posted on our LinkedIn. That's him and his phones.
So
looking
for
through the signals.
context, the table you see in front of you was a lot neater. We had it set up outside the presentation room, and we're going to bring it in. And about 30 seconds before the talk started, someone picked it up, the leg caved in, and everything you see on it spilled onto the ground, including the breadboard, which spilled like the transformer around. So halfway through the talk, I was like, guys, wait a second. And I had to go outside and like pick up bits off the ground and plug them back in.
Oh my goodness.
But the demo worked in the end. So, we're just for some content.
I couldn't find a photo of it on LinkedIn, but we definitely have one somewhere. But Nicola also built this really cool phone freaking challenge. And for those of you who aren't familiar, well, maybe Nicola can explain it better. Yeah, go ahead. I don't want to.
Yeah, what are you doing, right? Yeah, Nicola, take this wheel.
You're good. I think a bunch of people already referenced it in the chat, but like kind of just explain like the whole phone freaking thing, or yeah. So you could kind of say like before we really had computer hacking or cracking, however you want to call it, as a concept, say in the 60s and 70s and 80s, phone calls used to be really expensive. Well, back when these guys were around. And they were trying to, get rid of. Oh, sorry, my screen's a mess. They were trying to get rid of, human operators that would connect calls long distance. So AT&T developed, electronic switching systems. People realized, but this was before we really had computers. So these were controlled by like audio tones. You may have heard like the famous 2600 hertz tone that would control whether a trunk line was currently, active or idle. There were a few others involved, but people basically realized that they could play these tones themselves into the phone lines when they were making calls, and effectively trick, the phone switching systems into, doing whatever these phone freaks, they were called, wanted them to do. There's a lot of famous stories about the most basic one is basically they would cut off a call, start a new one, and then sort of manually dial digits themselves, really hand waving a bit. But they would basically make free phone calls by taking control of these phone switches. This was called like blue boxing. And there's a whole bunch of, probably fake stories about people, basically pinging around like through all these switching centers, through the trunk lines, like getting access to like the actual human phone operators who are still there, making like international calls, calling the Pope, stuff like that.
I remember hearing about repeat tones where you would dial a number and it would ring and then it would connect and you would get the dial tone again. And basically what it ended up happening was you had hit a switch box that would relay, and all you had to do was dial the number, and it didn't matter what number you dialed, it would make the connection. So if you knew where those numbers were, you could dial them, then redial for whatever number you actually wanted, and it would make the connection for free. Exactly, and another one was somebody, I forget the name, Captain Zap, if I'm not mistaken, hacked into AT&T or Ma Bell and changed one thing, AM to PM. And since anything in the AM was considered like super cheap call, or was it PM? I forget which was their height of it cost more money to call at those times because they made that simple change. It cost them millions of dollars in phone calls because the rates changed, thinking it was AM versus PM or vice versa. So it was really interesting. Those old school phone freakers, man, they really had some understanding of the phone system and how to manipulate it. It was crazy. I just remember seeing a blind kid that could whistle 2600 baud and make phone calls. It was, I feel like we missed out, right? Like
the classic one people usually tell is, I believe Steve Jobs and Wozniak might have even met making those blue boxes. I could probably search one up.
I think you're right. And that said, well, pre-show banter has been fun, kids. But it looks like it is at the 2:30 time, which means it is time for us to begin the show. and get into the actual MetaCTF challenges and those walkthroughs that you have been burning to understand. Maybe you're stuck. Maybe you're sitting there going, this is impossible. No one can answer these things. Well, we come to you with good tidings, because these young gentlemen here today are going to show you exactly all the little bips and bops that you need to know to solve these challenges. And Roman, I think we're going to start off with you, right? You're going to take the first challenge. What's our first challenge? And more importantly, what is its level? Is this a beginner challenge, or is this intermediate, advanced, that kind of thing? And what are some of the assumed knowledge bits that we might need to know going into it?
Yeah, so every Flash CTF, we usually try to have 5 challenges. And because we only have five challenges, we're kind of limited in the number of easy challenges we can provide. But usually there's going to be a relatively easy one that we hope that everybody can solve. The second one is usually slightly more difficult, but we're still hoping that the majority of people are going to be able to solve it. And then third, fourth, and fifth get more difficult pretty fast. With a fifth one that we usually expect only a few people to solve, if any. So the first challenge that we're going to be looking at is called, it's a forensics challenge called Browser Wowser. With a lot of these CTFs, you can't really go in. When we run these CTFs, we don't expect participants to know how to solve these challenges before they start. Part of the process of solving these challenges is trying to figure out what it is that you're looking at, trying to understand, what technologies it uses, what tools it uses, putting that into a browser, as a search query, and then finding some information on how to actually proceed. And so in here we're given, so I don't know if there's that much prerequisite knowledge that you can have with this one. But one thing that would be helpful to understand is the concept of just binary files versus like text files, files that have non-printable characters, and how different file formats work. And that'll help you with one of the solutions. So reading the challenge, it says, you're in charge of an employee investigation. It's believed that this employee may have viewed some really sensitive document in their web browser recently. Can you take a look at their browser history SQLite file to figure this out? So the first thing that you should take a look at is this mention to a SQLite file. If you've never used it before, SQLite is a database format that's very convenient and used for storing databases in single files. It's not usually when you have big websites, big applications, SQLite is not practical because it's pretty slow. It requires you to to have everything on disk, but it's a very convenient format that a lot of local programs and applications use to store data locally on the computer. I will copy the link and I'll share it in the chat here. So if you, the first thing you should do is figure out how to open SQLite files. One of the first tools that you'll find is called SQLite Browser. Before you install a tool like this, you should do some research to see how popular it is. Usually, you can look at GitHub to see how many stars it has, just to kind of get a sense of how trustworthy this tool might be. And often you can do this inside of a virtual machine. But SQLite Browser is a very popular tool that's used for kind of parsing SQLite files. You can use a command line tool, you can use Python, you can use whatever programming language you like. dbeaver, a bunch of the other tools have support for SQLite files, but SQLite Browser is a pretty good, pretty light tool. So I'm going to install it, get it running, and then I'm going to download the file and open it up in SQLite Browser.
Looks like Nerf Blasters had some good news for us, that if you are running Kali Linux, this is installed by default now. So that's good to know.
Let's see. I've set up a new profile in Chrome, and now it doesn't prompt me where to place my downloads. Yeah, so if you open up the file in SQLite, you'll see there are a bunch of tables, a bunch of indices, but the tables is where you should look at. I mean, in the challenge description, we're told to look in the browser history. So if we look through the tables that are here, we'll see that there's a table called history visits. So we'll start here. And if I right click and I browse table, they'll show me all of the entries inside of that table. This is not very helpful because it looks like it's referencing other tables. And if we look at often if you see some kind of ID as a column, that usually means it's referencing a value from a different table. So if you look at place ID, this tells us that there should be another table called places or similar that will have this information, more information about these entries. So if we go back to the list of tables and look through the tables, we'll see that there's the places table. So if I browse this table instead and look through the different information in it, eventually you'll see that one of these entries contains the flag. And if I make this bigger, you will see that this link was viewed and contains the MetaCTF SQLite isn't for a fight flag.
Yeah, Romy, can we go back to the places ID thing really quickly? How did you know? How did you know to make that connection? How did you know that the places ID was referencing other tables, and how did you know which table it was? Like for people that, like you said, this is a beginner friendly. Obviously, you're going to have to learn a little bit about SQLite, but that seems like oh, the answer to this question, to the answer to this problem is know how to use SQLite databases. How do you make that jump from I know nothing about SQL to this is where I'm supposed to go to find the answer to this problem?
Yeah, so I mean, the expectation is that it'll probably take you some time during the CTF to actually learn how to use this tool and do some research. I'm going to quickly address some of the questions. Some folks are trying to access the challenges. So if you go to this link, let me paste it. This will give you access to the May 2025 Flash CTF. And then I'm going to paste in. I assume Ryan can share them with everybody, or where should I post the link?
Yeah, Ryan's got it. It just showed up in
Yep.
in there, so it should be good.
So if you go to this link, you'll be able to access the 5 challenges that we're talking about. Also, as soon as the Flash CTF is over, we copy over all of the challenges to the practice environment. So if you simply create an account on MetaCTF and go to the practice link and like sign up for practice, it did not work. Oh, May 2025. Sorry. Yep.
Gotta love a good syntactical error there. He's a coder, everybody. This is what happens. This is how this works. Is you type in simple things and you always forget something simple. It's probably one of the more frustrating things about having to build stuff is that you're gonna forget, you're gonna miss a single quote, a semicolon, something somewhere. I did it today. I was like, oh, it's so frustrating.
Yeah, well, we changed it from 25 to 2025 because a lot of people were thinking that it's going to be on like May 25th or June 25th, and so that's why we decided to add the full year just to make it clear that it's the May 2025 Flash CTF. Or yeah, so you can actually sign up for any Flash CTF going back to like 2024. Or just say like GUN 2024 or like APR 2024. But if you sign up for MetaCTF and you look at the top at the list of available events, you'll see a practice environment, and that practice environment actually contains all of the challenges from our previous Flash CTFs in a single place. Once a Flash CTF closes, we turn off the submissions, so you can't change the scoreboard. But in the practice environment, you can still submit, you can still test flags. All of the challenges there have solutions published on our blog, and so it's not a very competitive environment, but it's a good place for practice. Going back to SQLite browser, one of the best ways to practice for these competitions is just by participating in these events. And so I probably should say that recognizing the fact that place ID implies that there's another table that this is referencing just takes some familiarity in working with this. But even if you don't find history visits, one of the other ways you can find the flag is by going through the tables and looking at the data. Let's see. I think if you look at the table settings, it will also tell you that place ID might be a foreign key. See history visits, place ID. No, I don't know if it actually has that, but sometimes you'll see that in these databases, it'll explicitly tell you that a certain column is referring to an entry from a different table, and usually that would be called a foreign key. And so it doesn't seem like it says it here, but that would have been a hint. Yeah. So if you look at the places table, if you just look at the data inside, you'll see the flag. This is one of the, I guess you could call this the proper way to look at it, the proper solution. But this is certainly not the only solution. SQLite format is not encrypted by default, and usually a lot of these strings that you see in the SQLite database are simply stored in the file as is. And what this means is that you can use a tool called strings to simply run to run against this file and extract all of the printable characters, printable series of characters out of this file. So let me give you an example. There are a lot of different text editors. They're really good, but I still really like to use Notepad++. And the reason for that is when you open up binary files in it, it's like just prints out the file for you. And this is what I was mentioning earlier about binary files. Any file you have is going to have, the entire point of files is to store some kind of information, certain bytes that you can then use with an application that you can read, you can do something with. And a lot of different file formats have special formats and the way they store data that if you only the program that's is designed to work with that file knows how to
Are you
parse.
talking about like magic numbers or magic bytes or whatever they're called?
Yeah, so the first few bytes of most files will tell you what kind of file format it is. If I look at a zip file, for example, like I downloaded DB browser, it will tell me that it's a PK file, and if I simply Google this, it'll tell me that it's a zip archive. Well, maybe not. But those are called magic bytes. And that's how you can recognize what the files are, even if you don't have the file extension. And that's how a lot of programs are able to parse these files, because they look at the magic bytes and they have a way to parse them. But so even though you can look at this data in a structured way, you can also look at the SQLite database simply as a text file and look at all the data stored inside of it. And you'll see that a lot of those URLs and a lot of those links are going to be explicitly printed somewhere in the middle. So if I simply search for MetaCTF, let's see. Oh no, I'm looking at the wrong file. Yeah, so in the SQLite file, you'll see a bunch of, well, I guess there's just a lot of null bytes. If you search for MetaCTF, you'll find the flag. And this is because the data that you're seeing in SQLite, has to come from somewhere, and it's stored in plain text inside of these files. Let's see, did it find it? Oh yeah, there it is. And so if you look at the Flash CTF and you see that some people were able to solve this challenge within a few seconds, that's probably how they did it. They simply used a tool called strings and ran it against this file to find the flag quickly. And so let me pull up the link again. So wget is a Linux command line tool to download files, and strings is a built-in tool that's used to parse these. That can look at the files like this and pull out all of the sequences of printable characters out of them, ignoring all of these random characters. And so if I simply run strings against places, it's going to give me all of these different strings. This is useful, but if I know that the flag is going to start with the words MetaCTF, I can pipe the output of this command into a tool called grep, and then search for MetaCTF. And this will print out the flag. Another way you can do this is by using a tool called CyberChef, and we actually link it right at the top of our problems page. And it has a strings. So if you don't have access to a Linux command line, if you want to do everything through the browser, you can simply upload this file here. Well, maybe not. And it'll print out the same output. And if we search for MetaCTF in this output, it'll also show the flag. So that's another kind of quick way to solve this challenge, but it's definitely not going to work for all challenges.
That's super cool because now you guys have got to see at least 3 different ways in which you could have possibly solved this challenge. And at this point, you're probably going, well, one was more easy than the other. So maybe if I'm working on a challenge, I want to start with the easiest stuff first. You start to build out your methodology for solving CTF challenges. And that's going to help you with the next one that you do because, hey, maybe this is a quick win kind of thing where I just strings a file and start grepping through for MetaCTF. And oh, look at that. There's exactly what I'm looking for. Or, okay, I didn't find that. Maybe I need to pull this SQLite database into somewhere else. And maybe I got to munch some data a little bit and start to work with it. You never know, right? That's kind of the fun part of it. And I love this one because it is beginner friendly. It allows you to just kind of go, okay, strings is easy. Looking at the file type is pretty easy. Understanding what a SQLite database is a pretty easy thing to do. Once I get those pieces together and I've learned enough about them, I should be easily able to go in there, find what I'm looking for, and get those points. So very, very cool. Anything else about this one that we want to talk about before we move on to the next challenge?
Well, once again, just it takes time. It takes practice, and just doing this over and over again. And that's kind of going back to hacker mindset. You just look at things, and you start to think of ways of, oh, how does this work? How can I look at this from different perspective? And so by participating in the CTFs, maybe the first competition you aren't able to solve a single challenge. The next one, maybe you can solve one or two, and you just do more and more of these, and that's how you kind of gain these skills and this mindset of being able to solve these challenges. And you can actually see the first one was solved by Michael in 48 seconds. So that they probably use strings. But yeah,
That's very cool. So moving on, right? We're gonna jump to the next challenge, right? Roman, are you taking this one, or is this Nicola, and what is the challenge?
I'll take this one too. So it's a cryptography challenge. In every Flash CTF, we usually have 5 categories. Sometimes instead of mobile, we usually have web exploitation, and we try to rotate the difficulties. So for example, 1 month, the easiest one is going to be forensics. Next month, the easiest one is going to be web exploitation. So we try to rotate these every month. This time, the second easiest one turned out to be cryptography. And it's called Frenzy, and it says, I was chatting with my friend while he was gaming to ask him for the flag. He did finally send me a message. It looks like he meant to send the flag, but it makes no sense. Can you help me? Here's the chat log. And you can read, there's a few messages going back and forth, and there's the flag. So I don't know if there's a good way to kind of figure out what the solution for this challenge is through some kind of method. A lot of cryptography challenges come down to kind of recognition, practice, kind of, and in some ways just creativity. Often you'll see, things encoded using a Caesar cipher, things encoded using base64 binary. For some of those, you can look at the alphabet and the characters used in the ciphertext, and kind of use that to understand what format you're dealing with. So for example, if you only see ones and zeros in a string, you can assume that it's probably being coded in binary. If you see a string that has 2 equal signs, 1, 2, 3 equal signs at the end, that usually means that you're dealing with base64. And these things, once again, just come with recognition and practice. The solution to this particular challenge is it's a keyboard shift cipher. I think that's a really fancy way of saying that this person just types the message on the keyboard but had their hands shifted. So if you try typing the word "the" and you just move all your fingers 1 character to the right, you'll see that the becomes Y, J, R. And that's pretty much how this message is encoded. So if you try typing this in on your keyboard, and you shift the placement of the key one to the left, you'll be able to get the flag. There are a lot of tools online that will do this for you. So for example, if you just search for keyboard shift cipher or something along those lines, you'll find a bunch of different tools that will do this for you. And pasting in the string in here will decrypt the message for you, like, pretty easily. So this would be the flag. If you couldn't guess what kind of cipher is being used here, we tried to throw in some clues, some kind of hints as to what it might be based on kind of the context and the scenario. But I'll probably say that the best other way to solve this challenge would be to try and map. Well, first of all, look at the string and try to see some patterns. So you see that in whatever the cipher is, capitalization is preserved. So for example, we don't know what this word is, but the first letter is capitalized. We don't know what these words are, but they're both lowercase. And then you expect the flag to be MetaCTF, and you see that these three letters are capitalized and these three aren't. So you can cross out several ciphers from the list that would change the capitalization. So for example, one of the most common ciphers you'll see is called XOR cipher. And if you type something in lowercase and you put in a key, in a lot of cases that will change the capitalization. Let me find something. Yeah, like it will change letters to numbers. It'll change things like that. So you can cross out some ciphers. A lot of ciphers that only have that don't care about case are things like Caesar cipher, a bunch of other kind of easier ones, and so those could be possible options. But the issue here is that you see that some of these characters have been converted to special characters, and so kind of if you can't figure out that it's a keyboard shift cipher just by looking at it, you can start looking at these different things that you notice inside of the cipher, and then try putting them in the search query to finally get to the point that will tell you that's a keyboard shift cipher. ChatGPT wasn't a tool, a few years ago, but it is a tool now, and so it's definitely something that you can use as well. In a lot of cases, when you're learning and when you're trying to solve, trying to learn something, we generally don't recommend to choose ChatGPT because it'll take away a lot of that learning process. But in a competitive setting, if LLMs and ChatGPT are not prohibited, then usually as a competitor, it's to your advantage to use every tool that you can find. The only exception to this rule is that we forbid paid tools, so that everybody who participates in these competitions has the same access to tools as everybody else. But ChatGPT will help you. I don't think it will solve it, but it'll give you a few options to look at, and it will tell you what it might be.
Well, that's definitely an interesting challenge for sure. Cryptography and cryptology, all those crypto challenges, they tend to get me pretty good usually, because I'm like, I'm not familiar with this. So I love that you did kind of like, hey, this does come from a bit of being around it. So if you're interested in cryptography, definitely start working on all the crypto challenges that MetaCTF has, because that's going to be the way you get used to seeing these things. And maybe, yeah, you could just pop this into ChatGPT or another LLM and say, hey, could you at least tell me what type of cipher this is? Could you lend me some way on how this has been obfuscated? And maybe it could be able to help you out with that. But a lot of times for me, it has just come down to the fact that, oh, I've seen this before. I've seen this weird gobbledygook, and I'm familiar with said gobbledygook. It's this, and some of them are not, kid friendly to say, but will be very useful to you in some ways. But very cool. So with that one down, we've got that one. That was Frenzy. Frenzy was a lot of fun. We're moving on. What's going to be our next challenge, and where would you rank that as far as difficulty goes?
So I'll yield the next one to Nicola.
Hey, is my audio still fine?
Oh yeah, you're good. Go ahead.
Sweet. So the next one, let me start my little 15-minute stopwatch here. The next one is Sela V, but Sela VMIE. So you can already kind of tell off the bat, it's probably going to be something related to virtual machines, VM, virtual machine. We can go ahead and download the files. 1 second, sorry. People can see that. Yeah, I've actually already gone ahead and done that. But so the two files that you get are going to be VM, which is an executable. And if you try to run it, it'll tell you that you need to run it on bytecode.bin. The other file that you got was called, what was it? It was, we'll get to those later. The other file, it was called chow.bin. Always start by running the file command on these things. File will analyze those magic bytes Roman talked about and tell you, what its best guess is as to what sort of file this is. So VM is just a regular ELF, meaning Linux executable. But chow.bin is just data. We can take a hex dump of it, get a closer look at it, and we might see some strings peeking through. It looks like it says enter flag and some other things, but no obvious leads. Whoops, I just locked my computer. Wrong button. You can still see it, right? I just keyboard shift ciphered myself by accident, actually. So when we try to run VM, it tells us, we need to supply it a .bin file. So let's try giving it shell.bin, and we can see it prints out enter flag. And we can give it a bunch of input, but it'll probably just say wrong flag. So we're kind of stumped there. So let's try loading this thing into a reverse engineering toolkit. It is a reverse engineering challenge after all, such as Ghidra. I've got Ghidra open right here. And I'm actually going to show you if you haven't used Ghidra before, I'm just going to show you the basics, right? You can drag in a file. This one already exists, so I'll need to name it like VM2 or something. It's going to ask you, you're going to have to click through a bunch of these dialogues that I think nobody ever reads. And then you're going to want to click this, you can either double click the binary you just dragged in or click the code browser button. Also, aren't those animations great? Sorry, Ghidra's a little confusing. Once you open up the code browser, you can drag from here into Ghidra. It's going to ask you, would you like to analyze it? Of course I would. You can click through all these dialogues, and after a little bit of processing, it'll drop you at the ELF entry point of this program. If we click our mouse there, this isn't like the main function that you may recognize as the typical C entry point. There's a little bit of boilerplate there, but you'll usually see like this libc start main, and you can just click on that first argument there. Again, as you decompile, sorry, I should give some context. What we're seeing on the left here is the disassembly of this binary. We can reverse off of this, but especially for a challenge that's relatively simple like this and cooperates, we can generally just go off of the decompilation. Ghidra famously, has a decompiler. It does a pretty good job these days. Oh, let me zoom in a bit on these windows so you can actually read them. So yeah, this is our main function. We can click any name basically and hit the L key to rename it. We're going to call this one main. It's so annoying how it brings those windows up on top. We know that main takes argc and argv. Those are pretty classic. So it looks like you'll usually recognize this is like, I want to say a stack canary or something. There's a bit of boilerplate basically that kind of always happens from the C runtime. We can ignore that. It looks like if argc equals 2, meaning we passed it exactly one argument, the first thing it does is it passes our argument to a function, and then it runs another function, and then it frees some sort of buffer, and then that's it. So I'm already 5 minutes in, so I'm gonna try and keep it pretty quick. We can hop into this function. It's pretty simple. We can see that it basically opens the file we pass it as a binary file in read mode. It does some seeking stuff. I'll skip over this. It basically, I want to say, this determines ftel in combination with fseek to the end, determines the length of the file we've passed it. Call that input length. And then, oh, never mind. I totally did that wrong, didn't I? Oh, no, we're good. And then it allocates dynamically a buffer that is long enough to hold the entire input file we passed it. And it reads the entire input file into, we'll call it input contents or something. Okay, so that's pretty straightforward. Let's hit, there's like a back button. You can also do Alt left to go back. Hit it a few times. Let's look at that second function, which we're going to rename process or something. This one's quite a bit bigger. Let me resize a bit. And don't worry, we won't go through all this. I have another one that I've relabeled, but I'll demonstrate a little bit how you might get started with this. Honestly, this one was just a lot of manual work to figure out what every sort of bit of this program does. But I will say one thing. The challenge is clearly like virtual machine themed. The program is called VM. You're passing it a file ending in .bin. And, clearly, I can also test, I can give it some random other file. Sorry, some other file. And it'll say invalid opcode. Only when I give it shell.bin does it actually seem to work. Off of this information, we can assume that this is a virtual machine of some sort, a bytecode interpreter, that shell.bin is some sort of probably custom bytecode that this program has been written to interpret and execute. And we know that 74, for whatever custom bytecode machine code this is not a valid opcode. So we know that at least. In fact, that's useful because if we go all the way down, oh, never mind. I'll never find that. If we wanted to, we could find in here the spot where it actually prints out invalid bytecode. I want to say it's this right here. Yeah, invalid opcode. So now that we know, we can actually place comments inside Ghidra. We can hit the semicolon and do, invalid opcode. And now we've labeled that bit. So, okay, I'm already up to 7 minutes, so I won't drag this on too much. But we can basically, in my opinion, the most underrated thing whenever you're doing any sort of static reversing is just renaming things. For me, at least, it can be a lot easy to lose track of how helpful it is to literally just rename the variables as you go. So, for instance, lvar13 has been set to point to the same place as input contents, which we can rename to program, let's say. So we can call this prog or something. This is going to be the program length. And this, we don't know what it is. It's some other, we can double click it. It's some other seemingly empty piece of, read-write memory. We can, it helps a lot that we know the rough flow of this program is going to be, of this binary, is we feed it in some sort of bytecode program, and it knows the length of that program, and it's probably going to execute it by, stepping through each instruction one by one until it's finished. So, we have down here, we have down here a condition that looks like if we violate that condition, this is just a stack canary. Let me rename this to stack canary. If this variable is greater than the program length, then we return. We exit. So presumably this is maybe the program counter that determines, where we currently are in execution. And indeed, since we've renamed that, sometimes there's some weird duplication of variables. This is maybe program counter 2. We'll get to why that's a thing in a second. As we rename things and as we scroll down, the program starts to look a little bit more familiar. Presumably, this is switching based on like the opcode, the current operation that is trying to be executed. So, if the opcode is 2, then it looks like we add something. Sorry. Then it looks like we grab something out of memory and put it somewhere else in memory. If the opcode is 3, it looks like we add 2 values and assign it somewhere in memory. If it's 4, we subtract. So you can probably start to get the gist that these are different like machine code, bytecode, opcodes of this custom like bytecode. One really nice thing is you'll start to recognize this over time. This whole thing here looks like it's basically doing an array access of some sort. I mean, it's taking the address of like a position in memory, it's adding some stuff to it multiplied by a factor of 4. So we need to tell Ghidra somehow that this is an array, probably an array of bytes. This has been really, I'm sure there's better ways to do this, but I always have to trial and error it a bit. You can hit Control L to retype a variable. So for this one, let's try just making it a byte, and let's give it a length of 256. That did not work. That also did not work. Let's see. I might have to swap over to the one where I did this ahead of time. Let's try byte pointer. Char 64. No luck. Yeah, Ghidra is sometimes really finicky, and I can never remember the proper incantations for retyping things. So let's swap over to where I did this ahead of time, and I can show you like sort of the proper decompilation. So all I did here was basically a series of the same steps I described. I went through renaming things one by one, retyping things one by one, until you can see this, the decompilation now looks a lot more readable. That array that was being assigned to, we can kind of assume it's a register file, because you've got a ton of these operations that are basically, and now it's really easy to talk about what it looks so clean on my screen. So for example, 3 we can assume is the add opcode, meaning it takes its first argument, basically off by 1 from the program counter and off by 2 from the program counter. It takes the registers that are referred to by these 2 arguments, adds the second into the first, and then assigns that to the register referred to by the first argument. And you can start to see things like, when an operation executes, the next instruction is going to be our current program counter offset by 3. The reason is you have your opcode, your first argument, your second argument. Confusingly, this is actually a variable, a variable instruction length. I guess we could call it an ISA if we want. So most of these, there's 2 arguments, so the next instruction is 3 away. But some of these, there's only 1 argument, so it's 2 bytes away to the next instruction. Some of these, it's 4 bytes away. We can go through, as I did, and sort of manually clean up this decompilation and get everything looking nice and good. At some point, we should probably start analyzing that actual chow.bin, that byte code we've been given. I dragged it into a program called imhex. Let's hope this opens up nicely. And by default, all you'll see is this top thing up here, which is just a regular hex dump. Something you can do that I personally find helpful when working with weird binary formats like this is basically change the word wrap to try and get an idea of like what the structure size is, how many bytes it is. Like you might notice if we drag this thing to 6 columns, things start to align nicely. We can see enter flag right here. We can see a bunch of characters in order. We can see flag correct and wrong flag. So there's some strings starting to peek out at us. Because this is a variable instruction with architecture, I'm just going to spread out a little bit to like 18 columns or something. That seems to render it nicely. There are honestly better ways to do this challenge, but because I wanted to play around with imhex, I wrote what's called imhex pattern language. I honestly don't know if I can recommend this. It's neat, but probably way over engineering. But basically, you can write a little program resembling C or Rust that, you start it off at address 0 in this program. You tell it how many instructions await it. And based on some conditions, in this case, the opcode, it will parse out, if, sorry, let me bring up the code browser. The first one we determined just loads an immediate value into a register. I'm out of time. I'll try and go like 2 more minutes over. The first, so, if the opcode is 1, we go to this thing at the bottom here, load immediate. We know that this takes 2 arguments, and all it does is the first argument, the register referred to by the first argument, it's just going to decode the second argument as like a literal value and place it in that register. So if I go back to imhex, that's what we do. We know that this has arguments register and just a value. So down here in the program listing, we can also hover over and see like the individual opcodes and the arguments and such. We can see that the very first instruction, it wants us to put a value 69 or capital E in register 0. And then what it does is store. I'm not going to explain every single instruction for brevity's sake, but basically it's going to take R0 and store it in like main memory at address C8, and then R0 at C9, and so on. So basically it's going to take enter flag and store it in main memory at this location. Once all that is done, you can scroll to the bottom here, it's going to do a string output, which basically prints all of this out to the user. That's why we see enter flag when the program starts. So now that we know that, we're probably going to have to do some manual reversing of this like custom assembly language. Let's see if I remember which one it is. So I think I dumped it from imhex into disasm.json, which was a bit of a mess. So I, me and ChatGPT wrote a program to clean it up. That's starting to look a bit nicer. We can cut out a ton of this code. I think I have, sorry guys, I'm very disorganized here. At this point, I personally just drag it into like a text file and start editing it by hand to clean things up. We know this first part is just basically printing out enter flag, and then it takes 32 characters of input from the user. We know that was input because it calls the function getC. Then it seems to load just a mysterious array of values into memory. And now here's like the meat of the program. Here's where it actually does some stuff. I won't go through this all in detail because I have it cleaned up in a different file. But you can see this is like the only spot where it's not just doing bulk operations like loading in or reading a lot of data. It's like actually chewing on that data. I have one instruction named what the heck because it doesn't really have any clear meaning. It kind of just like does some stuff to the argument. We'll get to that in a sec.
I think that was brilliantly named, sir.
Thank you. And finally, down here, this will print out basically flag correct. This will print out wrong flag. And we can back reference the locations in the program where these are, the addresses that these are at, to find that if this comparison succeeds, then we jump to flag correct. Otherwise, we jump to wrong flag. So from here, there's probably smarter ways of working with this. I kind of just, again, manually chewed through it. I have to remember these stupid file names I gave them. I believe it was halfway through core.c. So yeah, I just renamed it from those like moves and adds and jumps into something resembling slightly more like C code. We know where our input is, we know where the mysterious array is, and we know like the operations being done on these registers. From here, I found it helpful to just rename it from registers into like made up variable names, basically doing Ghidra. Yeah, it stands for what's the flag. Thank you. That is exactly what it stands for. And finally, we have something more resembling, classic source code. Basically, it's pretty simple when it comes down to it. It's going to loop from 0 to 32, non-inclusive, I believe. It's going to take the input at that index. It's going to run the what's the flag function, it's going to XOR it with what's the flag of the index, and then it's going to run what's the flag on that. And if that resultant character equals, the contents of that weird hard-coded array, if it doesn't equal that, then we're basically going to set a flag that we fail this check. If it passes, if everything matches as expected, then we succeed. I could reverse that thing there. It's all additions and multiplications and XORs, so it should be reversible. I felt that it was easier to just brute it, so I just wrote brute.py, which you can actually, because this is just a mathematical operation, you can pretty much just copy paste it out of Ghidra into Python. And then and then we know our hard-coded array of magic values that we need to get it to match in the end. So we can basically just, for every 32 expected input characters, we can iterate through every possible, 0 to 255, whatever, every possible input value, try running this sequence of operations on it, and see if it matches the expected output. And when we run that, we convert every input value to ASCII, and we combine them all at the end. And if we run that and enter it, it'll tell us the flag is correct. Hopefully that made sense. Sorry, I went a little bit over time.
It's okay. This is a much more complex, obviously, challenge than what we've seen so far, but it did introduce us to a lot of really interesting techniques and tools like Ghidra and was it binhex or I forget what the hex thing you were using was.
I used imhex, IMHEX, but yeah, honestly, any hex editor. A smarter approach would probably have been parsing this with a custom Python script or something. I just wanted to learn imhex and get it displayed all nicely for you guys,
Well, and that's the fun of doing the challenges, right? Is you get to mess with new tools, you get to learn new things, and obviously there's a lot to learn in this one because there were so many different things that I love how you had this trail of breadcrumbs that was okay. This builds to the next thing, and then that builds to the next thing, and so at the end of this challenge, if you started off not knowing anything about how to solve it, you probably knew a whole lot more than you did when you started at the end of it, because there's a lot of moving parts in there. So really cool. Somebody did ask in chat about Ghidra and MHEX. Could you give some links or just some good reference guides or resources for being able to get up to speed with those?
Sure.
And if you want, you can just drop those in the chat, and then we'll move on to the next challenge.
That sounds good.
And then that way we can keep things rocking and rolling. But I just wanted to make sure we got that addressed. That said, next challenge, what do we got on in the batter's box there? Who's going up?
Yes, I can do the next one. It's Gretel, which is a mobile reverse engineering challenge. I will say that all these solutions that we're going through right now, immediately after the Flash CTF was over, we actually publish written solutions up, and so they're all listed on our blog. So if you'd like to take more time and just kind of read through a solution instead of watching a video, you can go back and you can look at our blog. Also, in terms of practice, we have all of our challenges from our Flash CTFs are live, but we'll also give you access to our on-demand labs, which has 300, 400 challenges. For everybody who participates in the Flash CTF will get 1 month access to it, and so you can use that to practice as well. So going to the next challenge, usually we don't include mobile reverse engineering challenges in every Flash CTF. I think it's a relatively niche category, and often when we do, we'd usually just label it as some other category. But in this challenge, you're given a mobile app that keeps the encrypted flag safe, and you can download the app here. So if we try and download the file, we'll see that it's an APK file. An APK file is an Android program. So similar how you have the .exes, .msi programs for Windows, you have .apk files for Android. And so what we have to do here is reverse engineer that Android application. There are a lot of different tools that you can use. one of the most common ones that you'll see is called JetX GUI. I'm going to go ahead and download it. It's a pretty well-known tool, but it lets you take Android applications and kind of try do its best to compiling them. Android applications are usually written in Java, and even though Java is a compiled language, or I guess it's interpreted language, it's compiled to bytecode. You can often take this bytecode and you can kind of guess what the original source code was. It's not going to be exact, but it kind of gets you somewhat there. If you look at the releases for this tool, I'm going to download the version 1.51, the latest one. I'm going to get the one with the GUI and with the Jerry. So since it's a Java program, it requires a Java runtime environment. You can install it. Often it's just easier to get the tool bundled with the Java runtime environment, just so you don't have to bother with dependencies. But I'm going to extract it. Nope. And run it. Another tool that you might have seen in our blog was called, let me find it. Yeah, so this is the blog that we mentioned earlier. Every Flash CTF publishes the solutions there immediately. And I think the tool that we mentioned in the solution is called Bytecode Viewer. It does something very similar. You can use either JetX GUI, you can use Bytecode Viewer. You don't need to have a GUI. You can just try use a command line tool to decompile it. But if I drag and drop the Android APK into it, it's going to do its best and try to decompile the program. Sorry, I'm getting a phone call that I'm not sure how to disconnect. Decline. Okay. And if you look at the source code, often the application is stored in the COM folder. If you do some research into reverse engineering Android applications, that's where usually you'll see that. So COM. Sometimes you'll see a lot of other libraries that have been bundled with APK. Often when you see something that sounds similar to what the name of the challenge, to the name of the application, the name of the publisher, that's usually where the main code is. So if we go in there and we'll look at something that looks like main usually refers to a point in the program where everything starts. You have the main function in C, you have the main function in Java, and so in Android applications, you usually have some kind of main function as well. So if we open it, we'll be able to see kind of what this application does. There is some kind of function that gets you the ciphertext, which if we look at the challenge description, it will tell us that it's probably the encrypted flag, which we can see right here. And then you can see that it gets the key and it gets the IV, but it doesn't print them. The issue with getIV and getKey is that these are native functions, which means that they weren't written in Java. They're written in some kind of other language and compiled, and then loaded as a library, which means that we can't use JetX GUI or Bytecode Viewer to actually analyze what these values are. In the previous challenge, you've seen Nicola do something that's called static analysis. Essentially take a look at the program and try to go through its decompilation and try to figure out what it's doing step by step. That's called static analysis. Another way of analyzing programs is called dynamic analysis. And essentially what that means is instead of trying to go through every instruction, every function, and everything that it does, you instead just try to run it, and then you observe what's happening. So for that, we can use a tool called Android Studio. It's a tool published by Google for writing Android applications, and you can import the APK into the Android Studio. We're going to try and emulate it. So we're going to essentially run that Android application inside of a virtual phone in Android Studio. I think for a lot of people, it worked simply by using the default phone that was provided with Android Studio. For me, I had to set up a different one and actually root the device. And the way you can do that is you can click Create Virtual Device, pick whatever phone you want to use, and then instead of Google Play Store and Services, you pick Google APIs, and this system image will allow you to run or get root access on the virtual device. So that's what I have here. This Pixel 8 device has root access. And so I'm actually going to go and run it on this Pixel 8, and we'll see what happens. It might take a second for it to spin up. But this is the app, and you can see that when you click View Vault, it prints out the AES ciphertext as we see in this tool. So now we're trying to get these two values, get key and get ID. There's a tool called Frida. It's a reverse engineering toolkit that's used for dynamic analysis. And so this is the link. But by default, it comes with tools for analyzing Android applications. I'm on Windows, so my instructions are going to be slightly different from other operating systems if you're using Mac, if you're using Linux. But all I had to do was install Frida using pip, and then I had to essentially write a file to tell it how to parse how to parse it. So if I look at let me see. Well, okay. So first thing I had to do that is I had to install Frida server on this virtual device. So if I go to GitHub and I try to install it, code. If you go to releases, click Show All Assets, and we're going to have to get the Frida server for Android. I'm on x86-64, so this device is running x86-64. You can see it on set of settings. You can use a tool called ADB to see what the architecture is. But I'm going to download this file and place it inside of this folder. So I already did that right before the call. Let me see if I can find that in my system. Yeah, so I downloaded the archive. I extracted the archive, which contains this binary. And so using a tool called ADB, so ADB is a tool like a helper tool for Android Studio. You can use the push command to copy over this file into a folder inside of this actual phone. So I'm going to put it into data local tmp Frida server. So this just copied this file that we downloaded from GitHub onto this virtual device. I'm going to go run ADB shell, and this will give me access. Well, first I need to make sure that it's running as root. Exit. Okay, so it's already running as root. I'll go inside of the shell of this emulated Android device. Let me see if I can zoom in somehow. No, I'm not sure. But I'm going to go to the folder where I copied it to, which was in data local temp. List the files, and we see the Frida server file in there. I'm going to give it execute permissions. I can use set it to 755. And then I'm going to run it. What this does is it runs this Frida instrumentation kind of tool on the Android device itself, so that when I try to access it from my host machine, I can interact with that Frida server. So I'm going to open up another terminal, another command prompt screen, and one of the files that I added here is called hook.js. And what this file is a special Frida kind of script that tells it what to do at certain places inside the code. So you see that there's the main activity.getIV function, and I'm rewriting this function to instead call itself, but also print it. I'm doing the same for the getKey function, where I get the value of the function, I run it, and then in addition to returning it like it already does, I also print the output. And so if I run Frida with this file, so Frida-u, so what -u does is it looks at all the different USB devices and connects to them. And right now, it knows that Android Studio is running this virtual device as a USB file, and it automatically recognizes that. So it'll just find the first one and use it. So this is how we connect to this virtual Android challenge emulator. I'm going to load in the hook.js file that contains the our instrumentation code, and then I'm going to run the com.example_vol challenge function, which is what we've seen in JetX GUI, kind of contains the package that we're trying to run. So if I do this, it should relaunch the program in the emulator. And then when I click View Vault, in addition to printing the ciphertext inside of the program like it did, it's also going to print the value of the key in the IV function. So what we did is we essentially replaced these two functions with functions that do the exact same thing, but they also print the key and the IV. So now that we have the ciphertext, we have the key, we have the IV, we can plug this into CyberChef, or write a Python script or something and actually decode this data. So I'm going to go AES, decrypt. We have our ciphertext right here. So I'm going to put it in. We have our key. I'm going to paste it in, and we have our initialization vector. I'm going to paste it in, and that's the flag. Yeah. So the main thing about this challenge is that one of the easier ways to analyze this was to use the dynamic analysis and try to find, and instead of trying to reverse engineer everything inside of it, you had to use Android Studio or some kind of other emulator and try to use some kind of instrumentation tool to try and dynamically pull out these values. You could analyze this statically. So for example, we see that it's loading these functions from the native library, and if you look through the files inside of JetX GUI, you'll actually find in resources lib, you'll find this libnative function that contains the value of the key and the IV. Similar to the previous challenge, you can use Ghidra to analyze this, but it's been obfuscated, so you're going to have to take a lot longer. It's going to take you a lot longer to actually figure out what it decodes to if you decide to reverse engineer this statically. Yeah, once again, the solution is published in our blog, so you can simply go to this link and kind of read through it again and actually copy some of these functions that we've used to analyze it. And if you have any questions, you can post to Discord. We have our own MetaCTF Discord where you can kind of ask the community for help and for some suggestions on how to solve this if you're running into issues with any of these tools.
Yeah, always reach out to the community, right? Like there is somebody out there that has gone through the struggle or just knows what's going on and can help you out. I mean, it's a real trap that we can all fall into, and just thinking, I have to do this all on my own. I have to figure out everything here. I can use no helps. if I want to feel like I know what I'm doing. So please, out there, if you're listening to me, do not follow that trap. If you don't know what's going on here, that's totally fine. You're allowed to not know, but it's cool to go and ask people for help. It's cool to reach out to people, obviously in Discord and things of that nature, that can get you to where you want to go. Look at the blog write-ups for the walkthrough solution to see what's going on. Yeah, it might not make sense to you because it's out of your grasp at that point in time, but that's cool. You'll still be able to pick out pieces from it to move the ball a little bit further down the road, hopefully kick your can closer to the goal that you're looking for. Now, that said, Roman, I know that one was a doozy of a fun one, but I'm glad you did bring up some mobile stuff, because while it is niche, it is a sorely needed a niche that we need to start looking at more often. So I appreciate that happened. So we got one more. We're ready for that one. We're ready to do the last one. Finish off the 5 challenge Flash CTF challenge for May.
Yeah, I think I'll be doing that one. Right.
Awesome, Nicola. The floor is yours, sir.
Thank you. Yeah, so the last one is a binary exploitation challenge. It was this month. It was the hardest one, Galactic Archives. So it's got some nice little flavor text for us. There's some sort of terminal we can access connected to some sort of archiving system. And yeah, there's some records in there. We can actually, let's see, wrong window. Drag the terminal over. We can start by downloading the files, or I always kind of like when they give us a remote instance. Netcat is a really common tool that we use to connect to these binary exploitation challenges. It just opens like a TCP socket, you know. We can connect and take a look, and yeah, it gives us this cool little, you know, intro screen and a bunch of like records we can look at. So let's look at the first one. And yeah, there's a bunch of more flavor text. I think Sam did a nice job with this one. And we can exit to leave it. If we download that challenge file and extract it, again, there's more junk here, but what it will give us is archive, which is just a Linux executable again, as well as a Docker file. The Docker file is so that you can see how we actually deploy these challenges on the back end, so that your setup when you're testing can exactly, almost exactly, you don't have to flag, can match ours. So usually it's not too important, but in this case, we actually want to peek at it because it's got an important detail here. We can ignore a lot of this. This is using a container called redpwnjail that containerizes a lot of binary exploitation challenges. And it uses a Ubuntu base. So we also give you like a SHA-256 hash of that image. So if you want, you can, with some edits, you can build this and have like an exact recreation of the environment that we're running it in, which is really useful for more advanced Linux challenges. But in this case, it looks like it basically copies all the contents. Sorry. And this is a bunch of redpwnjail stuff that I'll ignore for now. But in /serve/app, that's where it's going to be running our program. It's it's going to copy that archive executable that we were given to /run, and it's going to copy the flag file, which we do not have, to serve-app flag.txt, and then it's going to rename it. You can try running this, but basically what it's going to do is rename it to flag _ a bunch of gibberish.txt. So we don't actually know the name of the flag file, which is important. This is also kind of a hint. The fact this is here hints us that maybe we have to do something involving like file paths. It sounds like we might not need to get like full shellcode, full RC, whatever on this application. We might just need to get it somehow to read that mysteriously renamed flag.txt file. And yeah, then it's going to make a directory for all those records, copy all of the like alien species, whatever it was, records over, and then run the application. And yeah, we can run archive locally. It's going to be the same thing, except there's no records available. I did make a folder called records, so we can go in there and create one. And now it'll show us that record exists. Okay, but we don't really know what to do here. We can try like flag.txt. It's not going to work. So yeah, we're not given any source code. So you bet what we have to do again is reverse engineer it. I've again opened up Ghidra. This time we're going to, for the sake of time, start with a bit of a head start. I've already, that's a spoiler. Try to get back to main. And this one actually exports a lot more. I think the binary hasn't been stripped, so like we can just go to the main function. And I won't reverse engineer all of it, and frankly, I have no idea why it's got like all these empty variables right here. But if we scroll through it a bit, it looks like it declares some stuff to do with directory entries. It does a bunch of like just debuffering, or what's it called, disabling block buffering. Here's like the intro little like what's it called, intro text that we're given. And right here, I've gone through and renamed this a bit, but basically what it does is it uses the opendir syscall, or C library function, I'm not sure which one it is, to basically look through all of the files in our current directory, right? That's how we indicate the current directory. And I think it's probably a linked list, right? It's going to walk, presumably, the linked list that this returns. And for every result it sees, it's going to read. It's going to read the results. And then, sorry, I'm trying to read this. Yeah, if it gets a null, it exits out. But if not, it's going to compare dname, which is the name of the directory entry. It's going to compare it against flag. And crucially, it's only going to compare those 4 characters. So basically, it's checking to see what starts with flag. So, does file start with flag? And when it finds one that matches, it's going to basically add a dot and a slash on the front and put it into a variable called flag file name. But unfortunately, all it seems to do is open that file and then read it, but then it doesn't look like it actually does anything with it. So unfortunate, but let's keep looking. Then it's basically going to do what we saw earlier. It's going to look into that records directory and do another opendir, readdir. I haven't bothered renaming this, but basically it's just going to find every file in the records directory and print it out in a list, right? We got that little bullet point there. It's going to ask us, what record do we wish to review, and then it's going to do the read chart function on it. Sorry, I'm trying to. And importantly, this local 138 is the first argument of fgets, so we could call this user input. It looks like it basically checks for the new line and chops it off with a null byte, checks if it's exit, etc. But in general, what we input to it is going to go to read chart. And I'm blazing through this real quick for the sake of time, but because it's in binary exploitation, a really common thing you might want to check is is it using like the getS function or any other obvious vulnerable classic C functions that you can just buffer overflow and take control of this thing. You can also use a tool called checksec. Do I have it here? I do. Checksec to check for common binary exploitation mitigations. I don't know why it doesn't autocomplete. Oh, sorry, it's just archive. And while there's no stack canary, it does have some of these other common protections enabled. So that plus the fact that there's no obvious use of getS or something like that. This is fgets, which has an actual maximum length argument, and so is a lot more secure. But there's no getS, there's no obvious mitigations disabled. So we're starting to feel maybe the solution to this isn't just buffer overflow it and get shellcode in there. So if we go into that read chart function, conveniently, we've actually, this binary hasn't been stripped, I think, of, I want to say, debug information. So we've got function names available to us. Again, param1 is user input. So it looks like it copies our user's input over to, I'm just going to call this also the user's input. It runs some sort of sanitize function on it, and then it tacks our input on, it tacks the result of that sanitize function, presumably, onto ./records. And then it looks like it just opens that file and prints the contents of it. This makes a lot of sense because, you know, if I go into records and I edit this, and then we run archive again, if I do ABC, you know, it sanitizes in some way what I've entered. It does it basically does cat records ABC, and we see that output. Sorry. So we start to wonder, you know, is there a way we can just let me make a better one to demonstrate. Let me make a file called like just flag.txt outright, and we're going to see if we can just do maybe /flag.txt, but no luck. It says not found, even though that is where it's located. We can try flag.txt. We can try the full path. It's not going to work. Spoiler alert. And the reason is that sanitize function. If we go into here, we can see, again, blazing over this real quick. It looks like it just does, and I've like retyped some things. I've made this a char pointer so that we get these nice like array index accesses. And these things are characters instead of like, you know, random decimal values. It looks like this basically just loops over the input string, you know, from 0 all the way to the null terminator. It checks if the character is a dot or a slash, and then it basically starts. It like skips by 1. It basically removes that character from the string. It does another loop starting at our current position, and, you know, ending at the null terminator, and basically like copies, shifts over characters to remove that, to remove that like offending dot or slash that's been passed in there. So, thankfully, a Ghidra's decompilation is, after some fiddling, is sometimes good enough that you can just outright copy and paste this into a test program. So I made test.c. I think I literally ChatGPT'd this because I'm that lazy for the, like, you know, input part. And then I get some input, I pass it to the sanitize function, and I show the output. So let's try and get an idea of what this sanitize function actually does. We could also do this, you know, by debugging this program, doing some dynamic analysis, and just, you know, putting a breakpoint and looking at what the output of sanitize is. But this is a little more convenient. So let's pass it, you know, flag.txt gets turned into flag.txt. /flag.txt. Interesting. It gets turned into .flag.txt when this thing is supposed to be removing dots. What about like 3 dots? Turns into 1. 4 dots turns into 2. So I won't get into like exactly the details of why, but basically because it skips over by 1 character when it sees like a character it's trying to remove. If your next character is one of those disallowed characters, it's not going to see it. It's just going to paste it into that position and then keep going. So if our desired outcome is flag.txt, then what if we do flag.txt? That actually becomes the output we're trying to see. However, we can't just pass this directly to the program, and the reason is that, however, we can test it. So, confusingly, however, I'm running like a million folders deep, so if we want to go up to like the root level, you know, if we want to do cat /etc/group, right? The problem is because this gets tacked into records, it basically does cat ./record/file name, and my input goes right here. There's no way to like erase that records and do like, you know, /etc/group. But what we can do is just dot dot slash dot dot slash dot dot slash over and over until presumably we get up to the top level. It doesn't really matter how many you put as long as you get beyond the required amount. And we can do like etc hosts. So that works. If we, sorry, this is going to be messy. If we try doubling up those characters, so dot 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 slash slash, every character has to be doubled. And if we spam a bunch of those and then do etc hosts, it doesn't work. Oh, because this also needs to be doubled, right? Let's spam a bunch again. Hopefully this works. There we go. Now we can basically output any file we want. The problem is, this is the last part, I promise. Remember that Docker file, because the flag on the remote system has been renamed to like flag underscore a bunch of random characters .txt, we don't actually know the name of the flag. However, if we go back a little bit, way back, too far back, we see that the flag was previously found by the program and opened, but they never bothered closing that. They never bothered closing that file descriptor. So we can actually abuse this a bit. Try and find the. So file descriptors are, is that a C? Or I guess that's a Linux kernel concept. When you open a file, the kernel gives you a descriptor, a number to reference it with. I believe file descriptor 0 is standard input. I'm not actually sure. 1 is standard output, and 2 is standard error. I might have gotten the first two of those swapped. But then the next file we open is almost certainly going to be file descriptor number 3. And we can access file descriptors in the /proc directory using something like this. Proc self fd3. Self just references the current process. We can, in theory, also reference others if we have the right permissions. So if we run archive, I'm going to need to spam a lot of these again because I'm running like many folders deep. But once we're presumably at the root level, we can tack on proc self fd3, and that will output the contents of that flag file that was opened. And indeed, if we cat, what did I call it? I called it like flag blah blah blah.txt. Yeah, we successfully read the flag. So now if I do netcat again, and I need a way shorter exploit for remote, if I try that, right, it's going to, when it sanitizes, it's going to de-double those doubled up characters, and we're going to go up to the root level and then proc self file descriptor 3. That's how we get our flag. Sorry, I went over time again, but does anyone have any questions about that? So
well,
somebody did ask.
It was definitely like, what was cool about that though is it had some classic foils, right? Like the fact that, I thought I was doing sanitation correctly, but what I was really doing was looking for this specific thing. And if it wasn't that specific thing, then it didn't get sanitized, right? It wasn't going to remove those characters. And you just had to be able to know what to do, to how to look into the code to find where that error was. And then you would be able to extrapolate that information out and be able to use it to your advantage. And of course, once you couple it up with the fact that you could then perform a // file, I'm forgetting the name of the actual exploit there for
File descriptor.
Yeah, not the file descriptor. When you do a / when you're basically
directory traversal.
Yeah, directory traversal. Yeah. Thank you. For whatever reason, it was escaping my mind. But once you were able to couple those two things together, it was like, money. I have a directory traversal, but it's being protected by the sanitization. As soon as I'm able to bypass sanitization, directory traversal was trivial to be able to read your flag file. So very, very cool stuff. A lot of people saying, nice. They love all this stuff. This is what we live for, right?
Someone did ask if you could do a cat asterisk, which you can on the shell, but asterisk won't work in here because this is calling, like the program is just calling open. Asterisk is like a bash shell thing. There's no file actually called asterisk, so that's why that wouldn't work. Sorry, just to answer that guy's question.
No, excellent, excellent, excellent. All right, well, that does it for the challenge. Thank you, Nicola. Roman had to jump out. He had some things to get to, but very, very cool stuff. Hopefully everybody found all the little bits that they were looking for. If they were stuck on a challenge and they were wondering, how the heck do you finally get past this? Hopefully this was helpful for you in being able to solve these challenges. That said, I did want to just mention the winners of this month's CTF challenge. I've got their names right here, which is Flockto and Amar. This is a fun AIMARDCR. Amadarker. I can, and then of course Mr. Alpha Q. Much easier to pronounce, but there you go. Those are your winners for this month. So if you want to be a part of this, you know what to do. You got to get signed up for the next challenge that's coming up for next month. Be on the lookout for that. Make sure you go to MetaCTF if you haven't already. Sign up. Get ready for this, because June's Flash Challenge is right around the corner. So start working your way through old Flash challenges. Look at the blog. Make sure that you're getting up to date, maybe picking up some new techniques, new tools, so you're prepared and ready for the next one that's coming down the pipe. That said, it looks like we are at the end of this. Again, thank you so much to Nicola and for Roman's coming and showing up and showing us what we can do with these things and how we can solve them. We really appreciate your time and effort on that. And until next time, kids, have a great day.